Number 1, find the area of the region bounded by the graphs of f of x equals x cubed plus x squared minus 72x and g of x equals negative x squared plus 8x. Alrighty, if you go ahead and get out your calculator and if you drew the picture, it will look f of x will go like that, and then g of x is going to go something like that. So you'll notice that there are actually two areas that I'm going to have to find the area of and then add them together. So for the first area, if I found this point of intersection, and it actually is happening at x equals negative 10, so the first area is going to go from negative 10 to 0 because that's where they cross again. And I notice that f is on top, so when I write this it will be f of x minus g of x dx, and then plus the second one is going to go from 0 to where they intersect, and they intersect at x equals 8, so I'll do 0 to 8. And this time g is on top, so I'll do g of x minus f of x. And even though that we're using our calculators to evaluate these, we definitely want to make sure that we have the integral set up correctly. And then from here, you could just, if you wanted to, type this entire thing in your calculator at one time, or you could find each part separately. I found each part separately, so that's what I'll write. I got 2166.667 plus 1194.667, and I made use of Math 9 to do that. And then when I add these together, I'll get 3361.333. Okay, problem 2. Let M be the region bounded by the functions y equals x squared and the x-axis on the interval 0 to 4. At what value k does the vertical line x equals k split M into two regions of equal area? So first of all, if I'm talking about a region, I'm going to go ahead and draw the region. We've got y equal x squared, and then we've got the interval 0 to 4. So it's going to be this graph right here. And basically what we want to know is where would I have to put a vertical line at x equals what to split that area into two separate parts. So my first step is going to be, let's find the total area. So to find the total area from 0 to 4, it will be from 0 to 4. And it's going to be the curve on the top. The curve on the top is going to be x squared. And the curve on the bottom would just be 0. And then from here, we could use our calculator if you want to, so I did go ahead and do that. And when I did that, I got 21 1/3. Okay, the second thing I need to do, if that's the total area, I would like the line x equals k to split M into two regions of equal area. So if I took 21 1/3 and cut it in half, each area would have an area of 10 2/3, and actually I wrote that as an improper fraction, which would be 32/3. So basically what I want to do is I want to figure out, this graph would have to go from 0 to what value of k so that I'd end up with an area of 32/3. So I'm going to go ahead and write my area. This time it's going to go from 0 to k because I don't know what k is right now. It's still going to be x squared minus 0. And I know this time I need my answer to be 32/3. So this one, since we don't have a k on our calculator, we're just going to go ahead and integrate it by hand. This would just reduce to x squared. So the integral of x squared would be 1/3 x cubed. And I get to evaluate it at k and 0. When I do that, I'm going to get 1/3 k to the third minus 0. And I do know that that's going to equal 32/3. So now I'll have 1/3 k cubed equals 32/3. The first thing that I'm going to do, because I want to get k by itself, is I'm going to multiply both sides by 3. And when I do that, I'll get k cubed equals 32. And then to get rid of the cube, we will take the cube root of both sides. So I will get k is equal to the cube root of 32. And I could leave it as a cube root of 32. But if I would like to make it a decimal out to 3 places, that answer would be 3.175. So when it said at what value k does the vertical line split it into two regions, that's where I would draw my line.